The first real images of Saturn. Do you love the rings around planets like me? Well, Saturn is not the only planet with rings, but it does have the most beautiful. The rings we see are made up of groups of small rings that surround Saturn. They are made of chunks of ice and stone. Like Jupiter, Saturn is mostly a ball of hydrogen and helium. Hello guys, welcome back to the channel All Things Space. We are back with another blockbuster video. In today's video, we'll explore the beautiful Saturn and its ring system, as well as its moons and most importantly, its surface and many other factors. Hold on, we are just going to start our video, but before that subscribe to the channel and hit the bell icon so you don't miss any upcoming videos. Let's start the video with its discovery. Exploration of Saturn. It's through space exploration that we've discovered most about Saturn, with 3 flybys in 2 years revealing the complexity of its world. The first was completed in 1979 by Pioneer 11, a probe designed to explore the outer solar system. His journey to within 200,000 kilometers of the planet revealed the existence of an additional ring. In 1980 and 81, Voyager 1 and 2 discovered several new satellites, revealing the complexity of Saturn's ring system and revealing high levels of nitrogen in Titan's atmosphere. The Cassini-Huygens probe, launched in 1997, reached Saturn on July 1, 2004. The Cassini orbiter should help us understand Saturn's magnetosphere and its interactions with its satellites, rings and solar wind. The European probe, Huygens, will be parachuted from the orbiter into Titan's atmosphere and take measurements as it descends. It's unknown what it will find on Titan's surface, but it should give us several minutes of data on the satellite's physical properties. It should also inform researchers about the planet's atmosphere and internal structure, as well as how the rings are formed. Surface, atmosphere and weather on Saturn. As a gas giant, Saturn has no real surface. Deeper inside the planet mostly swirls with gases and liquids. While a spacecraft would not be capable of landing everywhere on Saturn, it would not be capable of flying through unscathed either. Deep inside the planet, the extreme pressures and temperatures could crash, melt and vaporize any spacecraft attempting to enter the planet. Atmosphere and weather. Saturn is covered in clouds that seem like faint streaks, jet streams and storms. The planet has many unique shadows of yellow, brown and grey. Winds in the high atmosphere attain 1,600 feet per second in the equatorial region. In contrast, the most powerful hurricane force winds on Earth top out at approximately 360 feet per second, and the pressure, the same kind you experience when you dive deep underwater, is so effective it forces gas right into a liquid. Saturn's North Pole has a thrilling atmospheric characteristic, a 6-sided jet stream. This hexagonal pattern was first observed in photos from the Voyager 1 spacecraft and has since been discovered more accurately by the Cassini spacecraft. The hexagon, which is 20,000 miles wide, is an undulating jet that moves at 200 miles per hour with a huge rotating storm in the centre. There isn't any other climate feature like this anywhere else in the solar system. Interior study of Saturn. The low average density of Saturn is evidence of its bulk composition being mostly hydrogen. Under planetary conditions, hydrogen behaves like a liquid rather than gas at pressures above about 1 kilobar, which is equivalent to a depth of 1,000 kilometers below the clouds. There, the temperature is about 1000 K, 1340 degrees Fahrenheit, 730 degrees Celsius. Even as liquid, molecular hydrogen in a highly compressible material, and to achieve Saturn's average density of 0.69 grams per cubic centimeter requires pressures of more than 1 megabar. This occurs at a depth of 20,000 kilometers below the clouds, or about a third of the distance from the center of the planet. At a pressure of about 2 megabars and a temperature of about 6000 K, the liquid molecular hydrogen is predicted to undergo a major phase transition to a liquid metallic state, resembling a molten alkali metal such as lithium. This transition occurs at a distance about halfway between the cloud tops of Saturn and its centre. Evidence from the planet's gravitational field shows that the central metallic region is significantly denser than would be the case for pure hydrogen mixed only with solar proportions of helium. Excess helium deposited from the planet's outer layers may partly explain the increased density. Saturn's outer core of liquid metallic hydrogen is such that if slow circulating currents are present, as would be expected with the flow of heat to the surface accompanied by gravitational settling of denser components, there is enough dynamo action to reverse the observed magnetic field of the planet. Thus, Saturn's field is produced by essentially the same mechanism that produced Earth's field. The striking change observed in the rotational period of the magnetic field over the past 25 years may be related to the action of deep electric currents involving the conductive core. The most likely explanation for the additional energy source needed is that inside Saturn, helium has precipitated from a solution of hydrogen, forming dense raindrops that fall. As the helium droplets in the metal phase of hydrogen rain into deeper levels, potential energy is converted to the kinetic energy of droplet motion. Saturn's internal heat source then dampens this movement and converts it to heat, which is carried to the atmosphere by convection and radiated out into space, extending Saturn's internal heat source. Moon system. Saturn has a variety of intriguing and unique worlds, from the nebula-shrouded surface of Titan to the crater-riddled Phoebe. Each of Saturn's moons tells a different part of Saturn's system's story. Currently, Saturn has 53 confirmed moons, with 29 additional tentative moons pending confirmation. Largest moon of Saturn. Titan is Saturn's largest moon, and the second largest in the solar system. It is the only moon in the solar system with clouds and a dense planet-like atmosphere. Titan's atmosphere is active and complex, composed primarily of nitrogen 95% and methane 5%. Titan also has the presence of organic molecules containing carbon and hydrogen, often containing oxygen and other elements similar to those found in Earth's atmosphere, which is essential for life. The Cassini spacecraft has detected polar winds that pull methane and nitrogen past Saturn's magnetic field and out of the atmosphere. A similar process is believed to take place on Earth with our magnetic field. Titan known as the Magic Island. Methane lakes are abundant, which are mainly concentrated near the South Pole. In 2014, scientists found a transient feature that they playfully named Magic Island. Nitrogen bubbles formed in Titan's oceans may remain on the surface for a time, creating a temporary island that eventually disappears. Large areas of Titan's surface resemble the Namibian desert in Africa. Because methane exists as a liquid on Titan, it also evaporates and forms clouds, occasionally causing methane rain. Clouds of methane, ice and cyanide gas float over the lunar surface. Sunlight is quite weak on Titan, and the climate is primarily determined by changes in the amount of light associated with the seasons. The ring system of Saturn. Scientists think that Saturn's rings formed when either a large moon got too close to Saturn and was ripped apart by intense gravity, or the rings are just leftover material from the time Saturn was formed. The rings are gradually being pulled into Saturn and will disappear completely within 300 million years. We don't know why the other giant planets Jupiter, Uranus and Neptune don't have such a stunning set. On August 1st, 2010, this entry was published. Life on Saturn. Saturn's environment is not conducive of life as we know it. The temperatures, pressures and materials that characterize this planet are most likely too extreme and volatile for organisms to adapt to. And with that, we've come to the end of our video. Share your thoughts about the video in the comments below, and don't forget to give this video a thumbs up. Subscribe to our channel and we'll see you next time. Goodbye and thanks for watching.